Assalamualaikum warahmatullahi wabarakatuh. My name is Haikal bin Abbas and my metric number is A179855. And today I will do my poster presentation for scientific communication. And my poster title is The Influence of Environmental Polycyclic Aromatic Hydrocarbon, PAH, Exposure on DNA Damage Among School Children in Urban Traffic Area in Malaysia. I will divide my poster into certain parts so I can explain it more detailed and briefly. Okay, we move on to the first part of the poster, which is the abstract. So the study is aimed to investigate the association between the particulate polysaccharide aromatic hydrocarbon, PAH exposure, and DNA damage in Malaysian school children in heavy traffic, HT, and lower traffic, LT area. PAH sample at 8 schools were collected using low volume sampler for 24 hours and quantified using gas chromatography mass spectrometry. 228 buccal cells of children were assessed for DNA damage using COMET-AC. Monte Carlo simulations also was performed to determine the incremental lifetime cancer risk, ILCR, and to check the uncertainty and sensitivity of the estimated risk. The total PAH concentration in school at high traffic area were higher than a lower traffic area LT. And the degree of the DNA damage was significantly more severe in children at HT group compared to the LT group. And this study shows that the total PAH exposure was the most significant factor that influenced the DNA damage among children. And further investigation of relationship between PAH exposure and genomic integrity in children is required to shed additional light on potential health risks. Then we move to the introduction part. So what is polycyclic aromatic hydrocarbon? So polycyclic aromatic hydrocarbon or PAH are ubiquitous, semi-volatile and persistent organic pollutants that are formed by byproduct from the incomplete combustion of organic materials. And the exposure to genotoxic substances such PAH can cause oxidative stress that can lead into DNA damage and disturbance in DNA replication and then can cause mutation. So the study is carried out to fill the knowledge gap on the association between PAH from traffic emission and the chronic health effect concerning DNA damage among Malaysian children in urban city of the Klang Valley. Then we move on to the study location and population. So Klang Valley was selected as the location for the studies because it is known as the fast growing area and most populated area in Malaysia. And these studies include a total of 228 school children studying at a selected primary school in Klang Valley. The specifically age of the children is between 7 to 11 years old. So as you all can see, the selected section in Klang Valley is Gombak, Kuala Lumpur, and Hulu Langat. Then we move on to the methodology. Firstly, the researcher will do a questionnaire, which is a total of 280 questionnaire and consent form were distributed to each school, and 228 respondents completed the questionnaire and gave consent for the biological sampling, representing 81.4% of total response rate. Then PM 2.5 sampling were done, where a total of 64 samples and 8 blank samples, one for each school, were collected during the sampling campaign. Mini-volt air sampler was set up on the ground at rate of 5 liters per minute at indoor and outdoor for 24 hours. For indoor monitoring, the sample was placed at the back of the selected classroom, and for the outdoor sampling, the sampler was conducted at the main entrance gates of the school or guard posts. Then PAH extraction were done. The PAH sample was extracted from the filter paper of the air sampler and quantified using gas chromatography mass spectrometry GCMS instrument. And there are certain pH were determined, such as 3-ring pH, 4-ring pH, 5-ring pH, and 6-ring pH. 2-ring pH were exceptional because it is highly volatile. After the PAH extraction were done, Comet assay were done, where is the buccal apolitical cell of children were collected for the analysis of DNA damage using Comet assay. So as you all can see in figure 2, there is the Comet assay kit, and in figure 3, there is the human buccal apolitical cell. So I will explain a little bit about how the Comet assay is done. After the apical apolitical cell were prepared and placed into the slide, it was placed on the electrophoresis slide tray, and the alkaline electrophoresis solution will pour in the tray until the label covered over the slide. Then the electrophoresis will run for 20 minutes at 21 constant voltage, and the slide will wash twice in deionized water for 5 minutes and then wash once in 70% ethanol for 10 minutes in room temperature. After the slide dry, the slide was stained with 50 microliter SYBR green, and the comet image were captured using fluorescence microscope under 20 times magnification. Okay, then we move on to the result. For figure 4, it shows the concentration of total pH indoor and outdoor environment at each school. So the result clearly showed that the higher concentration of outdoor total pH was seen in high traffic school compared to the low traffic school, with the highest concentration recorded at H1, then closely followed by H3, then school H4, and then school H2. And on the other hand, the school at the low traffic group portrayed a low pH concentration, especially at school L3 and L4. The main reason why H1 has the highest pH concentration because it is located less than 50 meters away from the main road and 160 meters away from the highway. Meanwhile, the L3 that have the lowest concentration for pH is because due to the less traffic densities in L3 area. And the school environment is also surrounded by forests that may act as a natural filter that can contribute to removing air pollutant. Thus, it can lowering the concentration of total pH. Then we move on to figure 5, which shows the indoor to outdoor IO ratio of pH concentration in each school. So if the IO ratio were higher than 1, it indicates that the indoor sources are stronger than the outdoor sources. While in the other hand, if the IO were lower than 1, the indoor sources are relatively weaker. And all schools have IO ratio below than 1, ranging from 0.86 to 0.99. It indicates that the indoor sources are relatively weak. And the L2 recorded the highest ratio of 0.99. And this situation can be explained by higher penetration of outdoor particles into indoor classroom, resulting in higher IO at L2. This phenomenon may be due to the indoor and outdoor air exchange due to the natural ventilation system, which refers to the opening of windows and doors in the school. In addition, the windows in L2 were open most of the time, which increased the airflow into the classroom. So figure 6 show the probabilistic distribution of ILCR for children in HT and LT group. Monte Carlo simulation was performed to make accurate cancer risk estimation of PAH inhalation as shown in figure 6. And the mean value of probability cancer risk for the high traffic and low traffic group were 1.5 exponential -7 and 7.59 exponential -8. So basically, the higher traffic group has more probability to have cancer risk than children in the lower traffic group. And the TEQ value reported in the study, except for school L3 and L4, has exceeded the maximum permissible risk level of 1 nanogram per meter cube of BAP as set by European guideline. So the result shows that the tail movement of parameter of DNA damage of the high traffic group were significantly higher than the value recorded in the low traffic group with P lower than 0.05. And the individual factor of the tail movements was stratified and compared using independent t-test and one-way ANOVA as shown. And children aged from 10 to 11 years old have significantly high tail movement compared to children aged 7 to 9 years old. And children who are exposed to the environmental tobacco smoke, ETS, have higher tail movement compared to the children who not exposed to the ETS. And this also confirmed that the PAH is affecting the tail movement, which is the parameter of DNA damage. And we can see from the result that PAH is significantly damage the DNA. And based on the result that has been shown, the tail movement of children that exposed to the PAH in their environment, which is in school and also at home, have significantly higher tail movement compared to the children who expose less to the PAH. A simple linear equation is made, and table 2 is the result, which is the factor that influencing DNA damage among children after controlling all co-founders that we stated in table 1. And it is true that PAH can cause DNA damage because, as we can see, it predicted that every unit increases of exposure to total indoor PAH will lead to increment of log tail movement, which is DNA damage, by 0.063. And there was a significant direct linear relationship between total indoor PAH with DNA damage, and the present study strongly suggested that DNA damage is significantly affected by indoor particulate PAH after controlling all possible co-founding factors. The finding provide evidence that children living near busy roads are more likely to expose to environmental PAH and have higher risk of genotoxicity than children living in low traffic area. And this study has successfully reduced the knowledge gap between relationship of urban traffic pollution and genotoxicity in children in the Southeast Asia region. And these studies recommend increasing the distance between the future school site and busy roads to reduce the children exposure from PAH from the traffic, and the traffic density around existing schools should be reduced to provide a safer environment for school children. And that's all from me, Ahmad, Haikal, and Ahmad, and I hope you all enjoy my poster presentation. Feel free if you have any questions or suggestion about my presentation. Thank you, everyone.